Take a deep, slow breath in, letting the cool, quiet air fill your lungs. And as you exhale, allow your body to settle completely into the soft support beneath you. Tonight, we journey to the sheltered floor of an ancient gorge, where we will observe the patient, gentle erosion of canyon walls. Imagine standing at the base of a towering, sun-warmed cliff, surrounded by the quiet majesty of the Navajo Sandstone Formation. Here is something most people don't know. These massive rock faces, which can reach up to 2,000 feet in thickness, are actually the fossilized remains of ancient sand dunes from the Jurassic period, formed roughly 190 million years ago. If you look closely at the illuminated wall beside you, you can see sweeping diagonal lines intersecting each other across the face of the stone. And this phenomenon is called cross-bedding, and it perfectly preserves the exact angle of the slip faces of those ancient, wind-blown dunes, freezing the ancient wind's direction in solid stone. Reach out in your mind and press the palm of your hand against the stone. It feels wonderfully textured, dry and gritty, like heavy canvas warming your skin. The rock here is composed almost entirely of quartz grains, bonded together over unimaginable eons. Quartz has a rating of 7 on the Mohs hardness scale, making it a highly durable mineral, yet it is constantly, softly yielding to the unseen currents of the air. This process, known as aeolian erosion, happens continuously as the breeze carries loose microscopic silica particles that act as a gentle, natural sandpaper. The wind sweeps through the canyon, smoothing the sharp edges of the gorge, grain by solitary grain, in a quiet, never-ending sculpture. The rock beneath your fingertips holds the ambient heat of the afternoon sun, radiating a deep, comforting warmth that relaxes the muscles in your hand and arm. What's fascinating is how this very warmth physically shapes the canyon around you. As the sandstone absorbs the sun's immense solar energy, the rock actually physically expands on a microscopic level. Then, in the cool, quiet hours of the desert night, the rock steadily contracts. Over hundreds of years, this daily cycle of thermal expansion and contraction causes the outermost layer of the rock to slowly separate and peel away in thin, graceful sheets. This is a highly peaceful, gradual process that geologists call exfoliation, nature's way of allowing the canyon walls to softly shed their outermost layers. As you stand in the stillness, listen closely to the ambient sounds of the gorge. Occasionally, you might hear the softest whisper, a gentle cascading sound of sand slipping down the sheer walls. When these exfoliated grains of quartz finally detach, they drift downward and settle peacefully at the base of the cliff. They do not just form random, chaotic piles. The laws of physics dictate that this dry, uniform sand naturally settles at an exact, predictable incline known as the angle of repose, which is always between 30 and 34 degrees. Because of this, the base of the canyon is lined with perfectly uniform, sweeping slopes of soft orange dust that blanket the edges of the floor, waiting to muffle your slow footsteps. As you begin to walk further into the canyon's depths, you notice the rock around you isn't just one uniform color. High above, the bright, vibrant orange gives way to sweeping, dark, shiny streaks, cascading down the walls, looking like ancient painted waterfalls. This beautiful tapestry is known as desert varnish. It is a naturally occurring dark coating composed primarily of environmental clay, iron, and manganese oxides. But it doesn't simply wash onto the stone. It is meticulously deposited by the wind and then oxidized by microscopic manganese oxidizing bacteria that live on the rock's surface. This living varnish grows at an astonishingly slow rate, often accumulating less than 1 micrometer, 1/1000th of a millimeter, per 1,000 years. Looking up at these dark streaks, you are witnessing an ongoing masterpiece of biology and geology that took hundreds of lifetimes to paint. Run your fingers along a section of the wall that is sheltered by a slight overhang. Here, protected from the direct rain, you will feel a complex, intricate texture beneath your fingertips, a network of small, hollowed-out bowls and delicate ridges that resembles a beautiful stone honeycomb. This delicate pitted lacework is called taphony. It is carved not by the wind, but by salt crystallization. When minute amounts of moisture inside the rock slowly evaporate into the dry air, it leaves behind minuscule salt crystals within the pores of the stone. As these crystals gradually grow, they exert just enough microscopic pressure to pry the individual sand grains apart, carving intricate, shadowed caverns and beautifully textured hollows into the otherwise sheer wall. Moving deeper into the narrows of the canyon, the light softens and the air cools beautifully against your skin. You can suddenly smell the rich, earthy scent of damp stone and growing things, a fragrance like fresh rain. The air feels surprisingly humid here. This is because sandstone is remarkably porous, with a porosity rate of up to 30% empty space within the solid rock. It acts like an enormous geological sponge, absorbing the rainwater that falls on the vast plateau high above. The water travels downward through the microscopic spaces between the sand grains at a glacial pace, sometimes taking centuries to percolate through a few hundred feet of stone before it reaches you. When that slow-moving, ancient water finally hits a layer of impermeable rock deep within the canyon walls. Like dense shale, it can no longer travel downward, so it is forced horizontally until it gently weeps out of the open cliff face. This creates a mesmerizing, lush microhabitat known as a hanging garden. Here, the sheer vertical rock face is cloaked in vibrant, living green. You can see delicate maidenhair ferns and bright yellow golden columbine thriving effortlessly on the vertical wall. They are sustained entirely by this ancient, slow-release groundwater, creating a quiet, hidden oasis that is entirely dependent on the canyon's slow, patient hydrology. Even the simplest forms of life here are active participants in gently shaping the stone. Look closely at the patches of pale mint green and crusty, vivid orange growing directly on the bare rock beside the ferns. These are crustose lichens. They are rugged pioneer species, and what's incredible is that they naturally produce weak organic acids, such as oxalic acid, as a byproduct of their existence. This gentle acid slowly breaks down the hard minerals in the stone, chemically weathering the canyon wall to create the very first microscopic layer of nutrient-rich soil. In the cooler months, any tiny droplets of moisture trapped behind these lichens or resting in the microscopic cracks of the taphony eventually freezes. Water is a unique element, as it expands by about 9% of its volume when it turns from a liquid into solid ice. This simple physical change, a process called frost wedging, exerts a staggering pressure of up to 30,000 pounds per square inch on a microscopic level. It acts as a silent, powerful wedge, softly popping loose single grains of sand to join the dusty floor below, continuing the canyon's gentle expansion in the quiet of winter. At your feet, a shallow, crystal-clear stream winds its way through the canyon bottom. The sound is incredibly soothing, a continuous liquid murmur that echoes softly off the smooth, curving walls. A gentle stream like this, moving at a speed of just 1 meter per second, carries enough kinetic energy to transport fine sand continuously in its current. This process is called fluvial abrasion. The suspended sediment in the cool water acts as a gentle liquid polishing compound, flowing constantly against the rock. It is this gentle, persistent polishing that carves out the breathtaking, undulating, wave-like curves of slot canyons, leaving the rock below the waterline feeling as exceptionally smooth as polished glass to the touch. If you look at the lower layers of the canyon, right near the water's edge, you might notice a subtle change in the texture and color of the stone. The rock here is finer, darker, and less gritty. This is siltstone. Siltstone weathers much differently than sandstone because its individual particles are microscopic, measuring less than 0.06 millimeters in diameter. Because the particles are so incredibly fine, siltstone erodes into gentle, rolling, crumbly slopes rather than sheer vertical cliffs. This provides a soft, gradual, heavily textured ramp that leads down to the water's edge, offering a comfortable place to rest and observe the water. Stepping safely away from the water's path, you might notice the undisturbed ground near the canyon walls is lumpy and dark, resembling a miniature black mountain range across the sand. This fascinating texture is cryptobiotic soil, often called biological soil crust. It is actually a living carpet made of cyanobacteria, mosses, and fungi that literally binds the loose, shifting sand together, protecting the fragile canyon floor from eroding away too quickly in the wind. It is an incredibly delicate ecosystem of its own, and a single footprint can crush a crust that takes up to 50 years to fully mature and regenerate. Hidden safely beneath this protective crust, the roots of specialized desert plants weave their way deep into the stone. Plants like the crevice-dwelling Hoover's desert parsley find a home in the tiny fractures of the canyon walls. These deep-seeking roots subtly secrete mild carbonic acid as they grow, used to dissolve the hard stone around them. By doing so, they gently extract essential, life-sustaining minerals like calcium from the solid rock, while simultaneously widening the microscopic fissures, becoming a living, breathing part of the canyon's eternal slow-motion transformation. Tracing your gaze upward from the delicate seeking roots at the canyon floor, you can take in the sheer magnitude of the layered walls, towering into the soft twilight. Consider the way human beings first began to make sense of these magnificent vertical landscapes. In the year 1669, a Danish scientist named Nicholas Steno looked at similar horizontal bands of sedimentary rock and established a foundational concept known as the law of superposition. By simply observing the quiet logic of nature, he realized that sedimentary layers are deposited sequentially. This means the deepest rocks at the base of the canyon are the oldest, while the highest layers forming the rim are the youngest. Stepping into a canyon is quite literally stepping into a colossal stone library, where the river slowly reads the pages backward through time. The highest layer of this library, often forming the pale sunlit rim of these grand chasms, is frequently composed of kaibab limestone. This specific stratum is approximately 250 million years old, built entirely from the accumulated, fossilized calcium carbonate shells of microscopic marine organisms that lived in a shallow prehistoric sea. Natural rainwater is slightly acidic, possessing a pH of about 5.6 due to dissolved carbon dioxide gathered from the atmosphere. When this gentle rain washes over the porous limestone, it creates a very mild carbonic acid that dissolves the rock on a microscopic molecular level. This patient dissolution creates a highly textured landscape of tiny sinkholes and caves, a geological formation known as karst topography. For thousands of years, early human inhabitants closely observed this weathering process. Indigenous tribes recognized the value of the resulting calcium-rich soil crusts, known as caliche, They carefully harvested this naturally occurring cement to create durable natural plasters for their dwellings, in working in harmony with the canyon's slow decay. Observe how certain sections of the cliff face bow inward, creating massive, deeply shadowed alcoves overhead. Beginning around the year 1190 CE, the ancestral Puebloans took shelter within these naturally hollowed walls. They recognized that these alcoves were formed by a process called differential weathering. This occurs when softer rock layers, like crumbly, fragile shale, erode at a much faster rate than the dense, resilient sandstone caps above them. The wind and seasonal moisture naturally hollow out deep, sheltered cavities in the sheer cliff face, leaving a sturdy roof of hard stone intact overhead. These ancient architects deeply understood the thermal mass of the canyon stone. They realized that these deep alcoves naturally regulated temperature, maintaining a stable, highly comfortable microclimate that hovers between 50 and 60 degrees Fahrenheit, offering a perfect refuge from the blazing desert summers and the freezing winter winds. Today, we know the exact years these ancient cliff dwellings were constructed through dendrochronology, the scientific method of tree ring dating. By analyzing the unique growth rings of the ancient wooden support beams found in these ruins, archaeologists can pinpoint the exact year a tree was felled. Some of the massive timbers in places like Chaco Canyon trace all the way back to the 11th century, standing as silent witnesses to the canyon's slow evolution. Moving forward in history, humanity's understanding of how these grand gorges were actually carved shifted dramatically in 1857. An early geologist named John Newberry was the very first scientist to correctly propose that gentle rivers were the true architects of the Great Canyons. Prior to his careful observation, the prevailing scientific belief was a theory called catastrophism. Early explorers assumed these massive gorges were simply giant fissures, violently ripped open by ancient catastrophic earthquakes. Newberry's realization relied entirely on a concept called uniformitarianism, a principle first introduced by James Hutton in the late 18th century. Hutton proposed a deeply comforting thought: that the slow, methodical, gentle geologic processes we see today, like a quiet stream carrying away a handful of silt, are the exact same steady forces that have shaped the earth over millions of years. He argued that nature does not require sudden violence to create majesty. It requires only water, gravity, and the patience of deep time. This persistent, gentle carving was definitively proven during John Wesley Powell's famous 1869 geographic expedition down the Colorado River. As Powell floated through the winding narrows, he carefully studied the water's flow and coined the term antecedent river. This describes a fascinating phenomenon where a river is actually older than the mountains rising around it. As immense tectonic forces slowly pushed the continental plateau upward over millions of years, the river patiently maintained its original course. You can think of it like a stationary saw, steadily cutting against a log that is slowly being pushed upward into the blade. The river didn't dig down into the earth. The earth slowly rose up around the river. Powell also documented the incredible mechanics of moving water, noting a strict rule of physics that governs the canyon's continuous erosion. A river's ability to transport sediment scales to the 6th power of its velocity. This means if a gently flowing current suddenly doubles in speed due to spring snowmelt, it doesn't just carry twice as much sand. It can carry an astonishing 64 times as much sediment mass. This finely tuned physical law explains how even a serene, meandering river can transport approximately 16 billion tons of pulverized stone to the world's oceans every single year. quietly deepening the canyon inch by invisible inch. During his quiet evenings studying the canyon walls, Powell discovered a profound geological mystery written in the layered stone, which he famously named the Great Unconformity. As he traced his hands along a specific, distinct horizontal line where two entirely different rock types met, he realized that over 1.2 billion years of geological history was simply missing from the visual record. The sedimentary layers from that unimaginable span of time had been completely eroded away, washed to the sea long before the newer sandstone layers were gently deposited on top. Standing before the Great Unconformity is standing before a gap in time far older than multicellular life itself. Today, modern scientists use highly advanced techniques to read the subtle history of the canyon's shifting sands. One such method is optically stimulated luminescence, or OSL. This incredible technology can determine the precise moment a single, microscopic grain of quartz sand was last exposed to daylight. When quartz is buried in the dark depths of a canyon terrace, it begins to trap natural environmental radiation within its crystalline structure. By bringing these sand grains into a darkroom laboratory and stimulating them with a specific frequency of light, scientists can measure the trapped energy they release. This allows them to calculate exactly how many thousands of years ago that specific grain of sand was buried by an ancient, slow-moving flood. For the oldest, deepest layers of the canyon, geologists employ an even more profound method known as uranium-lead radioisotope dating. Deep within the metamorphic rock at the very base of the canyon floor, there are microscopic crystals called zircons. Zircon crystals are incredibly durable, capable of surviving billions of years of intense pressure and erosion, completely intact. When these crystals first form, they trap tiny amounts of uranium inside them, but they strongly reject lead. Therefore, any lead found inside a zircon crystal today can only be the result of the slow, completely predictable radioactive decay of that original uranium. By analyzing this delicate ratio, scientists have been able to definitively date the deepest, darkest rocks at the base of the grandest canyons, formations like the dense, shimmering Vishnu schist. The results reveal that these foundational stones are nearly 2 billion years old. This is nearly half the age of the Earth itself, resting quietly at the bottom of the gorge, softly smoothed by the cool passing water. The scale of time held within these walls is immensely comforting, a reminder of the slow, steady endurance of the natural world. Standing quietly at the deeply ancient base of the canyon, where the oldest stones rest against the earth, lift your gaze to examine the striking, warm colors painting the rock layers directly above you. You might wonder how solid stone achieves such vibrant, radiating hues of deep crimson, rust, and mustard yellow. It is captivated to realize that this is the exact same chemical reaction that causes a forgotten iron garden tool to slowly turn orange when left out in the rain. This patient process is called oxidation. In these towering, porous sandstone walls, just 2 to 3% of trace iron minerals is enough to dye an entire cliff face. When the iron slowly oxidizes, it creates a mineral called hematite, which yields a rich, brick-red color, or limonite, which produces a soft ochre yellow. The entire canyon is, in essence, gently resting and rusting in the dry desert air. Notice how the massive boulders resting near the riverbank lack any sharp, jagged edges. They resemble giant, perfectly smooth river pebbles, polished and rounded by time. This is the result of a geometric phenomenon known as spheroidal weathering. Think of what happens when you place a square ice cube into a glass of water. The corners and sharp edges melt away much faster than the flat sides because they are exposed to the water from multiple angles, eventually leaving a perfect smooth sphere. The exact same physical rule applies to stone. Within these massive boulders is a common rock-forming mineral called feldspar. When exposed to the gentle ambient moisture in the canyon, the feldspar undergoes a delicate chemical alteration called hydrolysis. Through this reaction, it transforms from a hard, rigid crystal into a soft, yielding clay known as kaolinite. It is much like a hard, dry biscuit, slowly softening and losing its shape when dipped into a warm cup of tea. Follow the quiet path of the water, winding lazily ahead of you. The stream does not travel in a rigid, straight line. It naturally creates elegant, sweeping S-curves, known as meanders. To understand how water carves these beautiful, oscillating shapes, picture runners competing on an oval track. The water forced to travel along the outside edge of the curve has a greater distance to cover, so it must move faster to keep up. This creates a focused zone of higher kinetic energy, called a cut bank, which softly scoops away the outer canyon wall. Conversely, the water on the inside curve moves much slower. This subtle reduction in speed causes the water to gently drop the heavy grains of sand it is carrying, building a smooth, sloping beach known as a point bar. As you walk along these sandy interior shores, you are walking on land newly deposited by the gentle geometry of fluid dynamics. The river itself is an exceptionally meticulous organizer. It practices a highly efficient geological phenomenon known as fluvial sorting. It functions much like a mechanical coin sorting machine that effortlessly separates heavy quarters from lightweight dimes. As the water's velocity naturally fluctuates throughout the seasons, it deposits stones of identical weights and sizes in distinct, perfectly organized zones. The heavy cobbles and large gravels, known as the bedload, stay right at the bottom, rolling gently over one another to create the soft, rumbling acoustic hum of the stream. Meanwhile, microscopic clay particles, measuring less than 2 micrometers in diameter, remain suspended in the water column indefinitely. This delicate balance is called a colloidal suspension. It operates precisely like the way a splash of cream disperses and hangs completely suspended within a dark cup of coffee, gently reflecting the sunlight to give the river its soft, opaque, turquoise hue. Step up to the edge of the smooth bedrock shelf bordering the stream. Carved directly into the perfectly flat stone are small circular bowl-shaped depressions, holding perfectly still pools of clear, remaining water. These miniature basins are called sculpted potholes. They form through a beautifully simple mechanical process. During times of slightly higher water, small hard pebbles become trapped in an eddy, a localized circular current of water that spins endlessly like a tiny, gentle whirlpool. The trapped pebbles act exactly like a mortar and pestle resting on a kitchen counter. Spun round and round by the persistent, gentle current, the trapped stones slowly drill a perfectly round, polished cylinder straight down into the solid bedrock, leaving behind these smooth, quiet, reflecting pools when the water recedes. Look at the cliff wall just beyond this bedrock shelf. You will see thin, striking ribbons of brilliant white mineral cutting diagonally through the dark red sandstone, catching the available light. This is a soft mineral called gypsum, taking the crystalline form of selenite. It looks remarkably like ribbons of white vanilla frosting, elegantly squeezed between layers of a deeply colored cake. Gypsum is classified as an evaporate mineral. Millions of years ago, highly mineralized, subterranean groundwater filled the microscopic hairline fractures in the stone. As that water slowly evaporated into the dry desert atmosphere over millennia, it left these solid, gleaming white crystals behind to gracefully seal and heal the canyon's ancient cracks. Deep within the dry, sandy banks towering just above the waterline, an incredibly tiny, easily overlooked form of biological erosion is taking place. Certain specialized species of solitary bees, such as Anthophora pueblo, literally burrow directly into the vertical sandstone to build their safe, quiet nests. They operate like microscopic, incredibly diligent masons. These remarkable insects possess specialized, highly durable mandibles that allow them to scrape away the individual sand grains one by one. They carry a tiny drop of water, collected from the nearby river, to delicately soften the stone's surface. By doing so, they gently excavate perfectly round, insulated little tunnels in the cliff face to shelter their offspring, proving that even the most fragile life forms can shape the seemingly impenetrable earth. As you walk along the dry margins of the riverbank, the ground beneath your feet displays a distinct geometric pattern of hexagonal plates. These are desiccation cracks, formed originally in ancient soft mud. The visual presentation is identical to a tray of freshly baked brownies, pulling away from the edges of the pan as it slowly cools on a counter. When the ancient wet clay shrank as it dried beneath a prehistoric sun, it naturally pulled apart in these exact mathematical shapes. Later, wind-blown sand gently swept over the plain, perfectly filling those empty cracks. Over countless eons, microscopic amounts of dissolved calcium carbonate filtered downward through the sediment. This calcium carbonate acts perfectly as a natural mortar, gluing the loose sand grains together in a chemical process called cementation, permanently preserving those delicate ancient mud cracks in solid rock for you to observe today. As the evening shadows lengthen and the ambient temperature subtly drops, the atmosphere within the gorge undergoes a subtle, invisible shift. The air resting high up at the rim of the canyon cools much faster than the sheltered air resting at the bottom. Because cold air is denser and heavier than warm air, it naturally begins to sink downward into the gorge. This creates a gentle, downward-flowing breeze, known as a katabatic wind. You can feel it brushing past your shoulders right now, an invisible cooling current spilling smoothly down the vertical walls. It moves with a heavy, steady viscosity, behaving much like cool syrup slowly pouring down the curved inner sides of a large bowl. This sinking air gradually pools softly on the canyon floor, sweeping away the heat of the day and wrapping the quiet environment in a soothing, deeply relaxing evening chill. As the invisible, cooling katabatic breeze softly settles across the canyon floor, you might reach out to rest your palm against the sheltered stone beside you. Even as the evening air chills, the rock retains a comforting, deeply familiar warmth. This occurs because sandstone possesses a specific heat capacity of approximately 830 joules per kilogram per degree Celsius. In simple terms, this dense mineral structure excels at absorbing thermal energy slowly throughout the day and releasing it at an equally measured, patient pace. Reflect for a moment on how similar this geological property is to human memory. Just as this towering cliff face absorbs the sunlight and slowly radiates it back into the cool evening, we too absorb the passing warmth of our daily experiences, holding on to those quiet moments to comfort us long after the sun has set on a particular season of our lives. Take a deep breath of the cooling desert air. A highly specific, rich fragrance often emerges as evening moisture condenses on the dry canyon walls. That deeply comforting scent of damp earth and stone is called petrichor. It might surprise you to learn that this aroma is not actually produced by the rock itself, but by a microscopic organic compound called geosmin. Geosmin is created by streptomyces, a type of bacteria that thrives in the delicate sandy soils resting on the canyon ledges. When microscopic droplets of moisture land on the dry ground, they eject aerosolized molecules of this compound into the air. What is truly astonishing is our biological connection to this process. The human olfactory system is scientifically tuned to detect geosmin at a staggering sensitivity of just 5 parts per trillion. Anthropologists believe this is a profound evolutionary trait. Our ancient ancestors relied on this exact scent to guide them toward life-sustaining water in arid landscapes. When you feel an instinctive sense of peace smelling damp earth, you are experiencing a deeply ingrained biological memory of survival and relief. Listen closely to the profound quiet of the gorge. Occasionally, a single cascading bird call echoes down the vertical walls. This is likely the song of the canyon wren, scientifically known as Catherpes mexicanus. Their song is composed of a series of clear descending notes that perfectly match the downward sweep of the rock faces. The acoustic physics within a slot canyon are extraordinary. Sound waves travel through the dry evening air at exactly 343 meters per second. When these invisible waves strike the smooth, undulating sandstone, they do not simply stop. They bounce back and forth in a phenomenon called acoustic reverberation. Due to the parallel geometry of the sheer walls, a single note from a canyon wren can have a decay time of up to 3 full seconds. The canyon acts exactly like the hollow wooden body of a finely crafted cello, capturing the smallest vibrations and amplifying them into a rich, resonant music that vibrates gently against your own chest. It is easy to look at these massive geological formations and feel entirely separate from them. But the truth is intimately different. Take a closer look at the pale, crumbly bands of limestone resting higher up on the cliff face. As that marine rock is gently weathered by seasonal rain, it releases dissolved calcium ions, known as Ca2+, directly into the flowing watershed. This mineral-rich water eventually travels downstream, filtering into the groundwater aquifers that supply human communities. When you drink a simple glass of water, your intestines absorb those ancient minerals. Deep inside your body, specialized cells called osteoblasts take those exact calcium ions and use them to continuously rebuild your skeletal structure. Human bones completely regenerate themselves every 10 years through this cellular remodeling process. Quite literally, the dissolved walls of ancient eroded canyons are currently providing the structural foundation of your own body. You do not just walk through the natural world, you are physically constructed from it. Crouching down near the gentle stream, you can observe a handful of translucent crystalline sand grains resting in the shallow water. Because pure quartz is inherently transparent, it allows natural sunlight to penetrate a few millimeters deep into the interior of the solid stone. This creates a microscopic greenhouse effect inside the rock itself. Scientists discovered that highly specialized photosynthetic cyanobacteria, known as endolithic organisms, actually live inside the solid quartz crystals to escape the harsh ultraviolet radiation of the desert sun. While they rest safely inside the rock, they patiently convert light into energy. Floating in the water just above these grains are countless invisible diatoms, single-celled microalgae that play a miraculous role in our daily lives. As the gentle stream slowly erodes the sandstone, it releases microscopic particles of dissolved silica. The diatoms absorb this free-floating silica and use it to construct beautifully intricate, transparent, glass-like shells around themselves, called frustules. These microscopic glass-shelled algae rely entirely on the slow erosion of the canyon to build their bodies. In return, as they photosynthesize, diatoms produce roughly 20 to 50% of all the oxygen in the Earth's atmosphere. Every other breath you take, filling your lungs with calm, steady air, is a direct result of these invisible organisms feeding on the slowly decaying stone. Think of the canyon as an immense geological hourglass, only without a glass bulb to contain the sand. The river at your feet is carrying away the pulverized rock at an almost imperceptible pace. The average downcutting rate of a typical desert river is roughly 0.16 millimeters per year. That is about the thickness of a single sheet of paper. Over millions of years, this microscopic daily removal of material results in the excavation of trillions of tons of solid rock. This missing mass is so incredibly vast that it actually alters the fundamental physics of the local environment. Geophysicists using highly sensitive gravimeters have measured what is called a negative gravity anomaly inside massive gorges. The sheer absence of the eroded rock means the gravitational pull in the center of the canyon is measurably weaker by a few microgals than on the surrounding plateau. There is a comforting, larger philosophy written into this physics. Just as the canyon is made more profound and beautiful by the material it slowly releases, human lives are often shaped by what we gently let go of over time. The steady current of years carves away the unnecessary weight, leaving behind a deeper, more resonant space. You can view your own life's steady progression as a patient river carving through a high plateau. It does not happen in a single turbulent day, but over decades, the gentle persistence of your daily routines creates a profound, quiet depth. Even the dust that escapes this canyon has a grand, life-giving purpose. When the microscopic particles of eroded rock become too fine for the river to carry, they are swept up by the wind, becoming aeolian dust. This dust ascends into the upper atmosphere, traveling thousands of miles on high-altitude air currents. This arid, desert soil is incredibly rich in phosphorus, an essential nutrient for plant growth. Climatologists have tracked atmospheric dust plumes from arid, canyon-filled deserts, discovering that they deliver roughly 22,000 tons of vital phosphorus to the lush green canopy of the Amazon rainforest every single year. Without the dry, quiet erosion of these seemingly barren rock walls, the most vibrant, diverse jungles on our planet would simply cease to thrive. What feels like a slow wearing away in one isolated corner of the globe is actively providing the vital foundation for spectacular growth somewhere else entirely. Understanding this cycle brings a profound sense of comfort. Nothing in the natural world is truly lost or destroyed. It is merely gently relocated. The grain of sand that slips softly from the canyon wall tonight is simply beginning a new, quiet journey toward the sea, carrying with it the endless, patient promise of deep time. Notice how the fading sunlight completely alters the visual character of the towering sandstone. As the intense, direct rays of the afternoon retreat, the canyon walls appear to shift from fiery orange to deep, bruised shades of violet and indigo. To understand exactly why this breathtaking color change occurs, we have to look closely at the physics of human vision and the scattering of light. As the ambient illumination drops, your eyes naturally undergo a biological transition from photopic vision, which uses the cone cells in your retinas to detect bright colors, to scotopic vision. Scotopic vision relies entirely on your eye's rod cells. These specialized cells cannot perceive the red end of the light spectrum at all, but they reach their absolute peak sensitivity at exactly 498 nanometers, which corresponds to the blue-green portion of the visible spectrum. This biological quirk, known scientifically as the Purkinje effect, means that as dusk settles, the deep red iron oxides of the rock fade into darkness, while the cool, scattered blue light of the twilight sky is heavily amplified by your own optical biology. Accompanying this visual shift is a subtle change in the acoustic atmosphere of the gorge. Deep within the narrowest, winding sections of the Slot Canyon, the evening wind occasionally produces a very low, resonant hum. This gentle vibration is a perfect, natural demonstration of Helmholtz resonance. You can picture the canyon acting precisely like a massive, naturally tuned ocarina. When the cool wind blows across a narrow opening in the rock, it pushes a small mass of air inside. That internal air compresses, then naturally bounces back outward, creating a rhythmic oscillation. Because these hollow chambers in the cliff face are exceptionally large, the frequency of the sound wave they produce is incredibly low, often dropping below 20 Hz. This registers as infrasound. While it is too deep for the human ear to hear as a distinct musical note, your body can actually feel the frequency as a soft, rhythmic pressure resting lightly against your chest, connecting you physically to the breath of the stone. At this very moment, the dropping temperature triggers a cascade of invisible chemical reactions in the sparse vegetation clinging to the canyon margins. The air begins to carry a sharp, distinctly clean aroma, heavily reminiscent of medicinal herbs and fresh rain. This highly specific scent is emitted by the creosote bush, scientifically classified as Larea tridentata. Throughout the blistering heat of the day, the small olive-green leaves of this resilient shrub remain tightly sealed, thickly coated in a specialized resin containing a waxy compound called nordihydroguairetic acid. This resin acts as an impermeable shield, completely preventing vital water from evaporating. However, as the evening temperatures finally dip below 80 degrees Fahrenheit, the microscopic pores on the underside of the leaves, called stomata, slowly open to breathe. As they do, they release volatile organic compounds, primarily camphor and limonene, directly into the cool air. The result is a profoundly purifying, crisp fragrance that naturally clears the sinuses and deepens your breathing. Kneel softly on the canyon floor and press your fingertips into the cool, accumulated sand. If you were to gather a small handful of this loose earth and examine it under a high-powered scanning electron microscope, you would witness a striking visual history of how each individual grain arrived here. Sand that has been meticulously carried by the wind, known as Aeolian sand, looks perfectly spherical and heavily frosted, exactly like microscopic sea glass. This cloudy, rounded texture is the direct result of millions of high-velocity, microscopic collisions as the wind tumbled the grains against one another over thousands of miles. Conversely, if you sift through the fluvial sand right near the edge of the riverbed, the grains remain highly angular, sharp, and perfectly clear, resembling tiny shards of broken diamonds. The river water acts as a gentle, liquid cushion, preventing the brutal friction of wind transport and preserving the original crystalline geometry of the quartz. You are physically touching two entirely different narratives of erosion at the exact same time. In the sheltered alcoves, where the heavily weathered sandy loam has gathered into deeper pockets, a spectacular biological event is quietly unfolding in the dark. This deeply eroded, well-draining soil creates the perfect, true dry microhabitat required by a remarkable nocturnal plant known as the sacred datura, or Datura wrighti. This plant demands highly aerated soil to prevent its roots from suffocating. Right now, triggered entirely by the absence of ultraviolet light, the plant's massive trumpet-shaped blossoms begin to elegantly unfurl. This blooming process is remarkably rapid, taking precisely 5 to 10 minutes for a tightly coiled bud to expand into a 6-inch wide, brilliant white flower. Scientists discovered that the sacred datura times this rapid bloom specifically to coincide with the evening flight of its primary pollinator, the Carolina sphinx moth, Manduca sexta. Because moths navigate by moonlight, the blossom is exceptionally large and bright white, acting as a luminous biological beacon against the dark sandstone. As it opens, the flower begins exuding a heavy, intoxicating vanilla-like perfume that can drift for up to 5 miles on the quiet katabatic currents. The sphinx moth arrives on rapid hovering wings, utilizing an astonishingly long 4-inch proboscis to reach the sweet nectar hidden at the very base of the blossom. This delicate nocturnal partnership is entirely dependent on the slow breakdown of the canyon walls to provide the perfectly textured, sandy foundation the flower needs to survive. Rest your hand lightly against the sheer rock face one more time. Unlike touching a piece of cold metal in the evening air, the sandstone does not feel icy or shocking. It feels velvety and deeply neutral. This tactile sensation is governed by a property of physics called thermal effusivity, which measures how quickly a specific material can exchange heat with your skin. Because porous sandstone is filled with up to 30% microscopic air pockets, its thermal effusivity is quite low. When your hand touches the rock, the stone draws the warmth away from your body at a very slow, gentle rate, matching the peaceful, unhurried pace of the canyon itself. It feels less like touching a cold wall and more like holding a thick resting cloth. Look closely at the highest ridges of the canyon wall as the first faint light of the moon spills over the rim. Embedded within the dark, layered strata are occasional striking bands of a completely different mineral called calcite. Calcite is composed of calcium carbonate, and under standard daylight, it appears as a dull, milky white vein. However, in the dark, bathed in the very subtle ultraviolet radiation naturally reflected by the moon and stars, something deeply fascinating happens on an atomic level. These ancient calcite veins frequently contain minute, trace impurities of heavy metals, such as lead or manganese. In the language of quantum mechanics, these impurities act as activators. When an invisible ultraviolet photon from the night sky strikes the rock, its energy is absorbed by the activator atoms. This sudden influx of energy forces an electron to instantly leap upward into a higher, unstable orbit around its nucleus. Because the electron cannot maintain this elevated state for long, it naturally falls back down to its original resting position. As it descends, it releases that stored energy back into the quiet canyon in the form of a visible photon. This intricate subatomic ballet results in a phenomenon known as photoluminescence. To your adapting eyes, the pale veins in the cliff face appear to emit a very faint, ghostly, pale blue or soft green glow in the dark. It is an incredibly subtle light, requiring utter patience and absolute darkness to witness. The canyon walls are not just passively absorbing the night. They are quietly, actively generating their own soft luminescence, a glowing chemical response to the stars above. Every texture, every scent, and every soft light in this quiet gorge is a testament to the elegant, endless interactions of chemistry and physics. working together in complete harmony to shape the peaceful darkness. As the deep desert night firmly establishes itself within the gorge, the atmospheric processes around you begin a methodical, step-by-step shift toward absolute stillness. The ambient temperature steadily descends until it perfectly matches the dew point. When this precise thermal threshold is crossed, the local atmosphere reaches exactly 100% relative humidity. Because the cooling air can no longer hold all its dispersed moisture in a gaseous state, a quiet, invisible phase change begins. Microscopic water molecules in the air naturally slow their rapid kinetic vibrations. They begin to cluster together, seeking out tiny suspended particles of airborne silica to use as condensation nuclei. Gradually, these clusters grow heavier, transitioning smoothly from invisible vapor into heavy liquid dew that descends softly to coat every stone, leaf, and grain of sand on the canyon floor. Observe how the sheer base of the canyon wall responds to this newly settled moisture. A deeply elegant mechanical process of hydration unfolds within the solid rock. The ancient sandstone is composed primarily of silicon dioxide, a mineral that naturally attracts water molecules through a physical property called adhesion. Step by step, the water droplets clinging to the outer face of the rock are steadily pulled inward. Because water molecules also possess high cohesion, meaning they fiercely stick to one another, they drag trailing molecules along behind them. This creates a continuous, microscopic chain of water that actually moves upward, defying gravity, traveling through the interconnected pore spaces of the stone, which measure just 10 to 50 micrometers in diameter. Through this steady, silent capillary action, a dark, cooling band of moisture slowly creeps up the lowest foot of the cliff face, quietly hydrating the ancient stone in the dark. Resting directly on this dampened rock is a highly specialized organism, beginning its own step-by-step nightly resurrection. This is a rugged desert moss, scientifically known as Syntrichia canenervis. During the blazing heat of the afternoon, this plant survived by entering a profound state of biological suspension, known as cryptobiosis. It systematically shut down all metabolic functions and permitted 98% of its cellular water to evaporate, curling into tiny, black, brittle threads that look entirely lifeless. But as the capillary moisture from the stone now reaches its roots, a rapid, methodical recovery initiates. First, specialized, translucent structures at the tips of its leaves, called awns, actively catch the microscopic dew droplets. Next, capillary forces pull the water directly through the cell walls. Within a span of merely 10 to 20 seconds, the completely collapsed cells gorge on the liquid, inflating rapidly and transforming from brittle black threads into lush, vibrant green stars. Now fully awake in the safety of the cool dark, the moss begins the quiet, crucial work of cellular repair, fixing any structural DNA damage sustained during the harsh daylight. Direct your attention to the dark ribbon of the gentle stream beside you. The water's movement is undergoing a gradual mechanical settling. Without the thermal winds of the day to agitate the surface, the kinetic energy of the current dramatically decreases. The step-by-step process of sediment settling in a calm fluid is mathematically dictated by a principle of physics known as Stokes' law. This law states that the speed at which a particle falls through a liquid is directly proportional to the square of its radius. Following this exact mathematical rule, the slightly larger, heavier silt particles succumb to gravity first, sinking slowly to rest softly on the riverbed. Eventually, only the absolute finest clay particles, those measuring less than 2 micrometers across, are left suspended. Because they are so unimaginably small, their terminal velocity is incredibly low, causing them to drift downward at a rate of just a few millimeters per hour. Through this methodical gravitational sorting, the top layer of the water gradually becomes flawlessly transparent, transforming into a pristine, black mirror. High above the sheer walls, the moon slides into view, illuminating the gorge through a beautifully calculated transfer of light. The lunar glow travels precisely 384,400 kilometers through the vacuum of space before softly striking the canyon walls. The sandstone possesses a specific reflective property known as an albedo rating of roughly 0.30. This means the rock absorbs exactly 70% of the moonlight, holding that subtle energy within its mineral bonds, while scattering exactly 30% back into the air. This process diffuses the directional beams of light, bathing the entire canyon floor in a flat silver, shadowless illumination. It is a visual softness that signals the final completion of the day's active cycle. Deep within your own body, an identical step-by-step biological sequence is currently commanding your transition into profound rest. As your eyes register the darkness, specialized photoreceptors send a quiet signal directly to the suprachiasmatic nucleus in your brain. This structure acts as your body's master clock. In response to the dark, it signals the pineal gland to begin synthesizing melatonin, creating this vital sleep hormone by converting stored molecules of serotonin. Step by step, this melatonin flows through your bloodstream, gently lowering your core body temperature and signaling to every muscle fiber that the time for wakeful kinetic energy has passed. Simultaneously, your parasympathetic nervous system engages, taking full control of your vital rhythms. It activates the wandering vagus nerve, which applies a gentle chemical brake to your heart, slowing your pulse to a steady, resting cadence. The meticulous, step-by-step settling of the canyon perfectly mirrors the biological processes currently unfolding within you. Just as the river carefully drops its suspended sediment, your mind is gradually releasing the accumulated thoughts and heavy kinetic energy of your waking hours. Your body absorbs this quiet rest, much like the porous sandstone absorbing the evening dew, drawing the stillness deep into your joints and your cellular structure. The day's heat has completely dissipated. The heavy particles of thought have drifted down to the riverbed, leaving your mind completely clear, still, and perfectly reflective. Nature operates on a continuous, patient schedule of gradual restoration, proving that true recovery does not require effort or force. It requires only time, stillness, and a gentle surrender to the quiet mechanisms of the night. As the ancient, towering canyon walls stand silent guard over the resting earth, you too can completely yield to the slow, heavy gravity of sleep. Every breath you take is a steady, rhythmic carving of peace into your own foundation. Embrace these quiet truths as they settle into your consciousness. I am exactly where I need to be. My physical form is perfectly equipped for deep rest. I release the momentum of the day. My breathing is slow, steady, and effortless. I am completely supported by the heavy, silent earth beneath me. My mind is clear, resembling a still, dark, reflecting pool. I welcome the quiet, step-by-step restoration of the night. Every muscle in my body is heavy, loose, and completely relaxed. I am safe in this moment of profound stillness. The natural rhythm of the physical world guides me into deep sleep. I surrender to the peaceful gravity of true rest. My thoughts settle gently, like fine sand, drifting to a quiet riverbed. I am deeply comforted by the absolute silence surrounding me. I breathe in pure calm, and I breathe out all remaining tension. My cells quietly heal and repair in the safety of the dark. I am surrounded by a gentle, protective, ancient peace. My mind has become a quiet sanctuary. I am ready to accept the deeply restorative power of sleep. I sink effortlessly into absolute, unwavering comfort. The world is perfectly still. The night is entirely calm. Good night.